Let's hit lesson 1.4, absolute value. Okay, absolute value is a little strange. The idea is it's going to look like this. You're going to have two straight lines and then something on the inside. And the idea is that the absolute value of a number is just how many places away from 0 is that number. So like if you've got this number line, right, and you've got 0 right here, you've got 1, you've got 2, you've got 1, 2, 3, negative 1, negative 2, negative 3. This 2 is 2 places away from 0. This 3 is 3 places away from 0. So even though it's negative, we're going to sort of ignore the negative when absolute value is in play. So when you've got these two straight up and down lines, these bars, then we're going to ignore the negative on the inside and say that the absolute value of negative 3 is 3. That's the basic concept. So you just have to sort of accept that as being the thing, and then from that we build. Alright, the first equation they want us to do with this is x minus 2 equals 5. The absolute value of x minus 2 equals 5. Now, before I show you how to do it, I'm going to skip ahead and just show you what the answers are, because I feel like that'll make this make more sense before we start trying to solve it. There are two answers. One is 7, and one is negative 3. Why are there two answers? Because if I show you here, if I put in 7 for x, 7 minus 2 is 5. And the absolute value of 5 is 5. If I put in negative 3 minus 2 is negative 5. And the absolute value of negative 5 is also 5. So you have two answers. You have one that gets you to 5 and one that gets you to negative 5. So that's the flash forward. Now let me back up and show you how to actually solve it. So we're going to go x minus 2. We're going to say that there are two problems happening. We're going to get rid of the bars, and we're going to say x minus 2 equals 5 is the first problem, and x minus 2 equals negative 5 is the second problem. So if I go x minus 2 equals 5, then I can go plus 2, because that's a negative, plus 2, and x will equal 7. Right? And that was one of our answers from before, was 7. Now if I get rid of that, put the 7 up in the corner. It's happy little 7 playing around in the corner. Now we go back to x minus 2 equals negative 5. We go add 2, x equals negative 3. See that? Negative 5 plus 2 becomes negative 3. And that's our second answer, negative 3. Playing around with that 7. And the way we answer that is we say x equals 7 or x equals negative 3. I'm going to try that again with this, because as soon as they do this, when they assume you get it and they move on, it gets way more complicated. So I'm going to do this with another easy one. But we're going to say it's the absolute value of x plus 4 equals 8. So we're going to need two answers, one to equal 8, one to equal negative 8. So x plus 4 equals 8, We're going to subtract the 4, and we get x equals 4. 4 is one of our answers. You can see how it's building on the lessons from the last few. You have to know how to do the basic equation, balancing across the equal sign thing to be able to do this. X plus 4 equals negative 8. Minus 4 minus 4. X equals 8 plus 4 is 12. Negative 12. So it's 4 and negative 12. You see that? And if we plug it back in, just to try to prove that this isn't ramblings of a crazy person, 4 plus 4, you see I take that 4, I put it in for x, 4 plus 4 is 8. If I take this negative 12 plus 4 is negative 8, and the absolute value of negative 8 is 8. Because remember, when we do the absolute value, we're ignoring the negative. Okay. Maybe now we can... If this didn't make sense so far, go back to the beginning of the video or read the description in the Penn Foster, because that's critical for the next bit. If that didn't make sense yet, go back and rewatch. Alright, now, like I said, they immediately make it more complicated. The absolute value of x over 12.5 equals 2. I don't like fractions and I don't like decimals, and they put them both in the same problem because they hate me. So we're going to set that, we're going to get rid of the bars for a second. We're going to say that that is equal to 2, and then we're going to do a second one, x over 12.5, and set it equal to negative 2. Okay. So now we're going to multiply by 12.5, multiply by 12.5, 12.5 times 2 is 24, plus the 2 halves makes another 1, so it's 25. 2 times 12.5 is 25. So x equals 25. Now that's 2 times 12.5. It's the exact same problem, but with a negative. So x equals negative 25. And those are our two answers. Either x equals 25 or x equals negative 25. And if you want, you could plug it back into the original equation and test it out. Okay. This one is 5. Absolute value of 4x plus 3. Absolute value equals 115. Now, in the way the distributive property works, you can kind of think of these bars as being parentheses, because this 5 is trying to multiply both terms on the inside of the bars. It's multiplying that whole thing. So what we want to do is get rid of the 5. So I'm going to divide by 5, divide by 5. 115 divided by 5 is... I did this earlier, but I forgot it already. 5 goes into 11 twice, with 1 left over, 15, 23. 5 goes into 115 23 times. So now I will get rid of this and this. Drop down that 4x plus 3 equals 23. Okay, now I've got that. Now I can get rid of these bars. I'm going to get rid of that too. And I'm going to do 4x plus 3 equals negative 23. So remember, that's the basic gist of how to solve these, is to do the same problem twice but make the answer positive and negative. So subtract 3, 4x equals negative 26 divided by 4, x equals negative 26 divided by 4, which equals negative 13 over 2. And we're just going to leave it as a fraction because they didn't include decimals here at all, so we're just going to leave it as a fraction. Now over here, get rid of that stuff. Minus 3 minus 3, 4x equals 20. Divide by 4, divide by 4, and x equals 5. So our two options are negative 13 over 2 and 5. Boy, that looks real messy, I'm sorry. And in the realm of making things more complicated, yet again, they've got us solving. Example 4 is an equation where both sides have an absolute value. So they've got absolute value of 5x plus 3 equals 2x, or the absolute value of 2x minus 1. In the same way, we're going to just take this second term and do it as a positive and as a negative and see what we get from doing both of those. So we're going to get rid of the bars. We're going to solve this first one. I'm going to write this up in the corner. 5x plus 3 equals 2x minus 1. Okay, I'm just saving that for later. Minus 2x gives me 3x plus 3 equals negative 1. Minus 3 minus 3, 3x equals negative 4. Divide by 3, divide by 3, and x equals negative 4 thirds. And again, I'm just going to leave it as a fraction. Okay. Now, erase this. X equals negative 4 thirds. We'll put that over here. Got that right there. Now, we're going to make this whole term a negative, which means I'm going to parentheses it, put a negative outside, then I'm going to distribute that negative into the inside, right? So that's negative 2x plus 1, because a negative times a negative is a positive. So I'm going to make this a negative 2x and a positive 1. I flipped the signs of both terms. Now I'm going to solve again. Plus 2x makes 7x plus 3 equals 1. Minus 3 equals 7x equals negative 2. Divide by 7. And x equals negative 2 over 7. And there's our answer. Is negative 4 thirds or negative 2 sevenths. Two fractions. I know, it's gross. Whatever. If we put it back in, though, it would work out. I don't want to. I'm not gonna. But it would work. Okay, now that we've done the basics of... Well, it's not the basics. That's also a little complicated. Anyway, now that you've got, hopefully, absolute value, we're going to look at the special circumstances of an absolute value. Special circumstance 1 is, I'll just show you, 2x plus 4 absolute value plus 5 equals 5. Okay, so if we subtract the 5 and we subtract the 5, we get the absolute value of 2x plus 4 equals 0. Now, when there's a 0, that means there's only one solution. And because you can't do a negative 0. There is no such thing as negative 0. So there's only one solution to this. Instead of the 2 that we've been doing, there's only one. So 2x plus 4 equals 0. We get rid of the bars. We go minus 4, 2x equals minus 4, divide by 2, and x equals negative 2, and that's it, and you're done. So whenever you've got the absolute value bars and then there's a 0 on the other side, that's kind of what you want. It's easier that way. It's simpler. There's only one solution when the other side is 0. Okay, here's the next special circumstance. Absolute value of 2x plus 5 equals 3x. Is this going to be a special circumstance? I don't know. This seems odd. Okay, so I'm going to get rid of the bars and set a second equation down here. 2x plus 5 equals negative 3x. Negative 2x, and x equals 5 plus 3x plus 3x. That's 5x equals 5, x equals 1. That doesn't make any sense. I thought this was supposed to be a special circumstance. Oh, negative 1. Oh, this is an extraneous where x equals negative 1. Oh, I get it. Okay, here's why this is special. Okay, so let me follow this back through for a second. Two x plus 5 absolute value equals 3x. Okay, if I get rid of the bars and I just do 3x, then I'm going to get minus 2x, and I get x equals 5. Okay, that's fine. We're going to leave that there. Now I'm going to do negative 3x. I'm going to solve for negative 3x. I'm going to add that 5 over, or that 3 over, plus 3x, make it 5x plus 5 equals 0. I have to subtract this 5, minus 5, minus 5. 5x equals negative 5. Divide by 5, and x equals negative 1. Now that seems fine. We've had negative answers before. But if we go back to the original problem, and we put in negative 1, then we get negative 2, because it's 2 times x is negative 1. Negative 2 plus 5 is 3. The absolute value of 3 equals 3 times negative 1 is negative 3. The absolute value of 3 cannot be negative 3. So our first solution, 5, still works, but our second solution, 1, cannot work. So it's called an extraneous solution. Extraneous means like extra, but wrong. So it's like it's added on like a third wheel, right? There's 2 people on a date, and the third wheel is an extraneous person. They're extra, and they're not supposed to be there. There you go, extraneous solution. If you end up with a problem where both answers, like, let's say they didn't give this example, so I'm going to have to make one up. Absolute value of 2x plus 4 equals negative 8, like that. The absolute value should never equal an 8. So something like this would be no solutions, because the absolute value can never equal a negative. Does that make sense? Okay, that looks like that does it for this section. So I'll meet you at 1.5.